Next session is Curing the Rollup Ecosystem's DA Addiction, High-Speed EVM versus Statelessness. Please welcome Leona Hioki, Jack Saracco, and Patrick McCorry.
Hello, everybody. This session is about DA, stands for data availability. It's been a while. Data availability is under the discussion, even in crypto timeline. The data availability was quite technical term back to 2018 or 19th. Actually, maybe we didn't expect that. No, it's became so famous word in crypto timeline or whatsoever we can chat in. So data availability is one of the most important part of the security, especially in layer 2 ecosystem. Actually, it's very important for L1 as well, but yeah, it's well discussed in layer 2 context. And today we have our two people, which is super related to this topic. Patrick McCorry from Arbitrum and Jack Saracco from Plasma Free. So would you mind introducing yourself a bit?
Sorry, guys. Hi, my name is Patrick. So I guess an introduction. I work at the Arbitrum Foundation right now, and I've been working there for about 2 years. My job is mostly focused on governance recently, like DAOs and everything else. I'm sure everyone here has an opinion on the DAO. It's like the most hated thing in crypto at this point. But then historically, I'm a technical academic, so I did a lot of research in cryptocurrencies for about probably like 10 years, I guess, so probably a bit too long.
Hi, everyone. My name is Jack Saracco. I'm from Argentina, Buenos Aires, Argentina. I've been in the crypto space for about 8-9 years, and yeah, building Plasma Free to enable payments worldwide.
Perfect. So so let's talk about data availability first. So basically data availability, what's our technical term before? And what do you think about this importance in the future? So data availability will be more important topic in the future, or people will ignore that in the future. What do you think about that?
I can take a stab at it first. So to me, data availability is like a fundamental property of blockchains in general. And a really good way to illustrate this is the following. So I just want to get everyone's attention because I'm going to ask you a question. Who here has a cryptocurrency balance like has ETH or Bitcoin or any other token? Raise your hand if you have some tokens. So the question is, how do you know your current balance? Like, how do you know you have those tokens? Well, you need the data for that, don't you? So every new block publishes, the latest state of the system. You can, fetch all the data, you can execute on it, and you can compute a copy of the database, then you can look up your balance and say, oh, I do have 5 tokens, for example. So that's why data availability is like fundamentally important. You need the data just to verify what your balance is. But when it comes to L2s and rollups, it goes a bit further. So you can imagine there's a smart contract that sits on Ethereum, and this smart contract is holding billions of dollars. Now, Alice comes along, and Alice wants to, she's deposited money in this smart contract, and she wants to get her money back out. So the smart contract, sitting on billions of dollars, has to work out, is Alice entitled to withdraw her funds? And, well, the only way the smart contract can work it out is based on the ledger for the L2 systems, so like any L2 is a list of account balances. It needs to work out, well, according to the ledger, does Alice have this balance and can she withdraw her funds? In order for the smart contract to be convinced that Alice can withdraw her funds, well, it needs the data for that. So again, data availability is an important property because even the smart contract has to verify the data before it allows Alice to withdraw her funds. So we're never going to get away from DA, basically. So that's my stab at the answer.
Yeah, it's basically inevitable like that. And basically the Plasma Free have a unique solution to make it kind of less costly. So what do you think about the DA in their importance in the future?
I think the DA importance is vital because at the end of the day, it's a backend system that every single L2 is using. When module DA started appearing through different L2s, I think that's when the DA conversation came about on the cost structure of things and the scalability of usage either in L1s and L2s. And I think the importance of DA got like a narrative within the space, mostly based on cost, mostly based on data storage and how that can be handled. In the growth of the different L2s and the growth of the different blockchains for users, I think that in 2-3 years, DA will still remain as a fundamental part of the stack you need to have. But the conversation around the DA is gonna, in my way, standardized in a way, because the costs are gonna be reducing and the usability for the end user at the same time is gonna be massive. So it's like every single Web2 component that today you use on the back end, users at the end of the day, they don't know that they're using it, but they know it's there on the back end to be able to provide the value for the users. And within Plasma Free, we use EigenDA exactly to manage the data availability of the users and to be able to maintain the cheapest transactions possible, because having in mind Plasma Free is a payments-oriented blockchains for mainly stablecoin usage and microtransactions to come into place.
Do you think you have a kind of trade-off of the data availability, high cost, high security, or low cost, low security? Can we achieve kind of low cost, high security, for example?
Yeah, by having the DA, we have a stateless chain where we can have high security and low fees and be massively adopted by users, and we don't have the restriction of cost on the data side, which was something that we really seen and figure out on the tech part of things in order to enable mass adoption for the users and usability at the end of the day. We've seen every single L2 grow from cheap to expensive as the usability increases, and that's something that we want to mitigate directly in Plasma Free, that if we get 1 million users onboarding, we won't see a scale on gas fees on the transactional level, which that eventually makes it unusable for most of the people worldwide. Sometimes first world countries see $2, $3 transactions and think that's doable in the rest of the world. $2, $3 goes a much longer way. So we have to take it to cents in order to that happen, or micro cents in order to that make it possible, basically.
That's weird. So Patrick, so you're from Arbitrum, and the Arbitrum basically is what's aligned with the context of the plasma. Maybe it happened in 2020, right? And Arbitrum and optimistic rollups. How do you feel about the difference, current situation of Arbitrum, and what you intended when we see the optimist rollup emerged back to 2020?
Yeah, I mean, I guess in context on this, so Arbitrum was first, so the history of Arbitrum is quite funny. So Arbitrum, the white paper was published in 2017 at a conference called Usenix. And I wasn't working at Arbitrum at the time. I joined in 2023, so I observed all of this as an external observer. What was quite funny is that the Plasma paper came out, and then the Arbitrum paper came out, and they're both trying to solve the same thing, but one was written in an academic way that was really hard to understand. And Plasma was written in a very cryptocurrency way, whereas again, very hard to understand. You go through halfway through a paragraph and then it just drops off. Very, very crypto. But then since 2017 till at least 2021, when Arbitrum launched and obviously OP launched and other rollups attempted to launch, if you compare Arbitrum in 2021 to his white paper, it's very different. So one example is, and I always laugh at this, is the idea of a sequencer. So today we have this idea of a based rollup where there's no native sequencer. You can use the L2 stakers for this and you just rely on the smart contract. That was actually the original Arbitrum paper back in 2017. Then they decided that was a bad idea and they added a sequencer into the system. So from 2017 to 2021, you just saw the Arbitrum, because they're all academics from Princeton, so they weren't really part of the Ethereum community. Then you had the Ethereum community working on ideas, and then you had this mishmash for 4 years. And then roughly at the end of it, we all had the idea of, this is how we actually build the system and deploy it. So it was quite fun actually watching that. I wasn't involved, I watched it as an external observer. I was more doing research than building.
So it's so different from the original version of Arbitrum. And so how do you expect Arbitrum will change after this? For example, the maybe blob introduced by Ethereum core developers, and basically I believe that Arbitrum is using both L1 core data and also blob as well. So if you are aligned with the roadmap of Ethereum, what do you think is the biggest change after this for Arbitrum?
The biggest change. Let me see. So I think there's two parts to this. There's what can Arbitrum, the tech stack, do? Then there's Ethereum and how can Ethereum support rollups. So on the Ethereum side, maybe one thing to highlight is blobs, for example. Why do we care about blobs? I haven't heard of blobs, by the way. Raise your hand if you've heard of Ethereum blobs. Okay, cool. I just want to make sure I know what I'm working with here. So this is why it's important. So back in the day, before blobs were invented, in a transaction, you have something called call data. And call data is really saying, let's give the data to the transaction. The transaction can parse the data, manipulate the data, interact with the data, and use the data in any way that it wants. So one might be, like, let's say, verify a digital signature or something. The problem there is call data is really expensive because, well, it can potentially be manipulated in any way by the transaction, so it has to be expensive upfront. Where blobs were introduced, when was it, 2023? I'm trying to remember now, it was like 2-3 years ago. Blobs is basically saying, let's get this data onto the Ethereum blockchain, but the transaction can't actually interact with it. It's just a blob, it gets posted, and that's it. And then the question is, why are blobs useful? Why should we care about blobs if you can't even interact with it? And the reason why is because it goes back to that DA problem, the data availability problem. What blobs are really providing is proof of publication that this data was published and anyone in this room can get access to it. And for rollups, that's really useful. If I can prove that this data was published to anyone in this room, then I can guarantee that anyone in this room can take the data and then understand what the latest state of the system is for Arbitrum. So to me, blobs were really useful because they brought down the gas cost completely, and they really just provided that basic property that we need, proof of publication. Where on the other hand, I guess for the Arbitrum tech stack, this is probably the biggest change since I started. So when I started, the Arbitrum had a very restrictive license. It was BSL. You basically had to ask the DAO for a license, and no one was ever going to do that. So we changed the licenses that as long as you share a portion of your revenue back to the ecosystem and back to the DAO, you can modify the Arbitrum tech stack as much as you want. And that's really cool because what makes rollups really exciting is that you can have these crazy virtual experimental blockchains, but they still retain some security from Ethereum. So one example in Arbitrum is that we now have this new VM. Well, we have WASM. So you can now write like a Rust smart contract in Stateless, and then deploy your Rust smart contract, and it can interact with Solidity smart contracts. And that's really cool. You can do this now, and it's live. So to me, that's like the Arbitrum tech stack, and hopefully rollups in general should be very customizable. So then people can just add some code and try it out, and hopefully retain the security of Ethereum.
Yeah, sounds very interesting. I want to see that. It happens in many places. OP stack. It's commonly used in this space. On the Arbitrum as well. I want to see how it thrives. So Jack, plasma free, it basically goes without blobs. And it's not only because using ion layer. Basically, it's a unique optimistic architecture with ZK to remove the necessity of the blob or data availability in some contexts. Would you mind explaining the major difference between plasma free and the other rollups or the other layer 2s?
Yeah, absolutely. So plasma free is based on a plasma technology, which, as Patrick mentioned, was one of the ways to scale Ethereum. So the users, we enable basically the user to add a very low bytes from their end to be able to do the transactions and to be able to have the least cost possible on the data side. And that's what enables for us the more part of the scalability. Something that I also want to mention is we have a rollback function where users don't have to depend on the trust of the system. Where there's any transactions that weren't done, there's a force back transaction system where after X period of time, the chain is rollbackable to a certain state where it pushes to L1 and the funds are 100% secured for the user side. I think that's one of the key differences with the different L2s, where we provide the most amount of security for the end user for their funds to be there. Because at the end of the day, an L2 is running a different system from L1, has a different, it's like completely in a way parallel connected to L1, but whenever you push to L1 is when you really verify that the funds are there and they stay there. So I think that's a very important change, and that's a very different change that we've been doing on the tech side to enable security or prove security to our end users.
Yeah, so Plasma Free, it was proposed by Barry Whitehart.
By Barry, yeah.
It was quite interesting that 2023 he published a new Plasma, and the Plasma thought to be ended in 2090s, and people said Plasma is dead. But in 2023, Barry said that it's kind of Plasma is back, and this is like a complete version. He didn't say that it's a L2 because it's like rollback instead of rollup. Yeah. So, but it's quite unique idea to facilitate the new way of the securing layer 2 with extremely scalable way. And so what do you feel? Maybe you are in the Plasma, the community back to the 2080s or something like that, I guess. And so how do you feel about this? Talking about Plasma today.
I know it makes me laugh sometimes. No, it's just because like 2017 was just so chaotic. Like there's this really famous diagram for Plasma where there's like 200 different versions of Plasma, like Plasma EVM, Plasma something else, Plasma XYZ. And we spent like 2 years designing so many different Plasmas, but they didn't really go anywhere back then. It was so chaotic. It was so ridiculous on hindsight. But the reason why it didn't go anywhere it wasn't because like the idea was wrong. It was because we didn't understand the design space. And so if you don't understand the design space, well, you just come up with weird designs, don't you? But now we understand it quite well, and there's like 3 parts of the design you care about. One is data availability, as we just spoke about, state transition integrity, how do you guarantee that a transaction is valid, so you can go from one state to the next. And then the last one, censorship resistance, like how do you guarantee I can send a transaction and it's eventually going to get executed even if the sequencer goes offline. So now that we understand that design space much better, the question is what is Plasma and what is a rollup and how does it fit into that? And to me, the difference is a rollup, as the name implies, you roll up the data and you post it somewhere. That's the data availability problem. Where Plasma is, how do you just keep the data off-chain altogether? So you don't have to really post it anywhere. You can just make it available when needed. Or at least in the case of some of the Plasma designs, the user holds the data. It's not like it's widely broadcast. As long as the user has their data, then they can always withdraw their funds. So it's really just like playing with the design on how to do DA. And that, to me, is the real difference between Plasma and Rollups, which then hopefully implies that, well, yeah, Plasma is a cool idea. And now hopefully we can actually build stuff around Plasma that's, that works. Because, yeah, it was chaotic back in 2017.
I think that idea of having the entire user having the data instead of a different way of storing the data is what makes it more scalable in a way, because centralizing the entire data is 100% super costly compared to the users interacting with their own data. Obviously, you need the user to be interacting with the chain more often, and it's like part of the burden that the user will have, but that's what makes it scalable at the end of the day in the payments routed system or the micropayments rule that I think that some of the L1s are lagging on that side, which in my view, it's part of the entire market perspective of the payment side is micropayments a huge big thing within that. We all understand macro payments and how those works, but having the user interact with the data it's a pretty interesting way different to what Arbitrum's doing with the rollups.
Yeah, I remember that Plasma said to be dead, not only because of EVM compatibility. People said that it's because of the online assumption. No, people needed to be online, but actually, people are very often online. So yeah, it might be possible that we can throw away that kind of attack vector or the weakness. And
Well, maybe they had a bit of context. That's just so I can, like, for the online assumption for Plasma. So I think the problem, back in 2017, it was assumed that the end user had to be online periodically to keep their funds safe because there's a fraud-proof system there. So Rollups sort of solved that because the fraud-proof system was global and not local to the user. But obviously, if you have zero-knowledge proofs, then you could go back to the Plasma design, use a ZK proof, and then hopefully the user does not know. There's no fraud-proof, is there? You just prove that this is correct, and I hope my data is a user. So fraud-proofs are just tricky when they become local to the user.
And I think that also something that enabled this to happen was the CK cost and the CK growth. During the last few years, initially CK was kind of an idea, and the cost was pretty still comparable to certain L2s. And I think that the last 2 years, CK's tech has been there in order to make this scalable too. I think that's one of the vectors that also pushed Plasma tech to be able to be massified and usable at the end of the day.
so at last we talk some different topics like more general philosophy of DA and also how it affects on the other space. Do you have any idea this DA problem idea or concept can be used in another department context or the other tech context? Do you have any idea of that?
Yeah, to think about this, I've got like a very academic answer to this, so I don't know if people enjoy it or not. But if you think about DA, like data availability, like what you're really saying is you have a protocol or a system that you want to be publicly verifiable. What do I mean by that? So you can take the transcript of the system, you know, everything that it did, you can replay it yourself, and you can verify yourself that the system was run correctly, or the protocol run correctly, or everything's correct. And that's fundamentally where you want DA, because the transcript is the data that you care about. And a real-world example of that, where it always gets really tricky, is like voting. If you think about voting, you cast your paper ballot, and then it goes into the system, and then disappears, and then there's people in real life counting it, but it becomes like a headache. Like that, your paper ballot is technically the data that has to be available for people to verify that your vote is counted. So, but that's not really publicly verifiable. It's just verifiable to the system. It's not publicly verifiable in the sense that I can't come along and start counting your paper ballot. You have to trust people to do that on our behalf. But to me, that's like probably my answer to it. Yeah, voting is like an interesting example of it because we can't get it right, and that's why it's always controversial. But ideally, you'd want voting to be publicly verifiable and the data to be public in a way where I could check that it was done correctly.
I think exactly that. It's not in the many governments aligning. Sometimes they want to be shady with a few votes. Two other different examples that come into mind about like data storage in a way and how to make it more efficient is like I think today the legal structure of how the paperwork works, that's pretty inefficient. Legal could have some data availability improvements in a way. The other one is IDs for governments. Having to prove certain KYCs on-chain makes it like even faster with DA or like way more. You don't have to share all your information all the time, just like proving that you are someone with a valid ID. And I think that's at the same time providing the proofs that you have validated ID instead of having to share the entire ID or KYC every single time.
Basically, governments are experts of losing data and faking data, right? So do you think the blockchains or cryptography is the best idea to fix this point? Or do you think another perspective of that?
What a question that is. I mean, if you think about what a blockchain fundamentally does, and it's really boring what a blockchain actually does, a blockchain is basically there's a cryptographic audit trail. If you think about it, you have a list of blocks. Every block has a list of transactions or a list of actions. It's canonical. It's a time series. So blockchains do provide you this cryptographic audit trail, so you could go back in time to see what someone did. The problem is, people delete data, and they also don't want to be held accountable to that standard as well. I'm sure if some people read the news recently about some data being deleted, that would have been really useful for the crypto industry by certain government officials, but I won't go into it here. So yeah, what you really need is like someone to enforce that accountability so they use those systems so then you can't have that audit trail. And obviously people don't want that, so they avoid it like the plague.
You became a big man enough to avoid the drastic conversation here, maybe.
Yeah, I think that the data leakage from part of the garments is something super strange and funny. It happens. You think the governments should be protecting your data and your information truthfully in the most secure possible way. I find it super interesting. Like yesterday, Leona mentioned in one of his talks about different central banks being hacked, and pretty recent. Actually, I wasn't aware of that. You see, like the Russian or the, I think it was the Indian too. They hacked like 10 years ago, something like that. Those are things you don't expect, and sometimes enabling that data for multiple blackmail or different uses is what we have to fight against in a way.
Yeah, thanks so much. So, yeah, let's wrap up this session. And yeah, thanks so much for listening to the DA discussion. And is there any kind of one words about the DA problem and the roadmap or what you want to tell us on behalf of your project?
I mean, I was going to ask the audience, actually, maybe ask you guys, who's excited for DA? Raise your hand if you're excited for DA. Woo, DA! There you go, exactly. We're all excited for this, so yeah.
Just wanted to add that Platform 3, we're live in testnet, and soon we're going to be pushing out mainnet. So if everyone has their dApps, any builder here in the room, eager to talk and see how we can build stuff together. Thank you so much.
Thank you guys for listening to this discussion. So, yeah, thanks so much.
Thank you.